This video will go through problem number 1 from the 9-1 homework. So we will solve the system by graphing without a calculator. What I notice in number 1 is that both equations are in slope-intercept form. So for the first one, I plot the y-intercept at -7, and then the slope is -3/2, which means I go down 3, right 2. A common thing with negative slopes is people go down and left, which means you're actually doing a double negative. Oops. Okay, so now with graphing systems though, we have to keep going. So I'm going to rise 3 and go back 2. That's also a negative, or a negative slope. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. I do like to keep plotting points in the grid so that I have all of them. So this is my first line. I'll graph that in blue, and then I'll switch colors and I will graph my other line in green. So for this other line, I see that it has a y-intercept of 2. This one's rise 3, run 4. But you'll see if I keep going this way, it's not going to hit the line. So instead, I'm going to do a double negative, which is down 1, 2, 3, 2, 3, 4. So I can see that this is my critical point of intersection, which I believe is the solution. So it's at -4, -1. Now it is important to check just to make sure. So I take both equations, y equals -3/2 x minus 7. I substitute -1 in for y, -3/2 times -4 is the x minus 7. And when I simplify the right-hand side, I should get -1. -4, this would be -2, so I get +6 minus 7 is -1. So it works in that one, but I also need to check it in the other equation. So I take -1 equals 3/4 times -4 plus 2. Again, these will give me a -1, so I get -3 plus 2, which again is -1. So you can see that it does work. So that's how you solve a system by graphing by hand. Make sure you keep plotting those points until you find the exact point of intersection. And it's always a good idea to check your answers the way I showed here.